Hello, everyone. Well, if you have not had the chance yet to watch Digital Nation, please do. Here's the link to it. It's also found in your Moodle site, and there's a forum for it. It really is very interesting. It is a few years old, but it really shows us how digital technology has changed our world. So we're going to start today with Chapter 9, believe it or not, and then we're going to work our way back. We do that because this is something that's so you. You understand the internet, you understand technologies, and it's a great way for us to start. As governments, corporations, and public and private interests vie to shape the internet so it suits their needs, the questions of who will have access to it and who will control it are taking on more urgency. The internet was, and has been, free. And now people are realizing how to make money with it. So rules, regulations, laws, all those things come with money. So let's talk a little bit about the early days and the early history of the internet. The internet was developed by the U.S. Department of Defense in 1958 to compete with Russia during the Cold War. It was designed to develop and test technological innovation. In its civic roots, it was used by large research companies and many universities. It was called ARPANET at the time, or the net. One of the main functions of the early internet was email. It was developed by Ray Tomlinson, and it enabled researchers to communicate with each other and share research. They also used bulletin boards, which posted information on topics about health and technology and employment services. Now we're starting to grow. Microprocessors are developed in 1971, which enables the development of the personal computer. I can remember back in 1980 when I first went to college, don't do the math, I had a boyfriend who was a computer major. And it was when computers were first being developed. And the computer was the size of the entire room. And he used to bring me home things that he printed out, and they were the size of the entire dining room table with these little perforated edges. And he would write my name out, and it would print out on this big giant computer. And that was very exciting back then. As you see by the slide, the 1980s saw us move from the developmental stage to the entrepreneurial stage for the internet. Fiber optic cables were invented. These developed in the mid-1980s, and they enabled more rapid transit of information. ARPANET ends in 1990, and this allows for commercializations of the network in 1991. Web 1.0. This developed in the late 80s by Tim Berners-Lee, which you'll see a video of in a few minutes. He created this thing called HTML, Hypertext Markup Language. If you've ever taken a web class, or you're going to, I teach that class. It's interesting and fun, but HTML can be a really daunting language. It's just like any other language, like Spanish or Russian. You have to learn the code, and then you can create the sites. It allowed computers using different operating systems to communicate with each other using just one language. And then it allows the web browser to understand it and help you navigate through different parts of the web, mainly clickable links. This became the mass media stage.
Time flies. It's actually almost 20 years ago when I wanted to reframe the way we use information, the way we work together. I invented the World Wide Web. Now, 20 years on, Ted, I want to ask your help in a new reframing. So going back to 1989, I wrote a memo suggesting a global hypertext system. Nobody really did anything with it very much. But 18 months later, this is how innovation happens. 18 months later, my boss said I could do it on the side as a sort of a play project, kick the tires of a new computer we got. And so he gave me the time to code it up. So I basically roughed out what HTML should look like, hypertext protocol, HTTP, the idea of URLs, these names for things, which started with HTTP. I wrote the code and put it out there. Why did I do it? Well, it was basically frustration. I was frustrated. I was working as a software engineer in this huge, very exciting lab. Lots of people coming from all over the world. They brought all sorts of different computers with them. They had all sorts of different data formats, all sorts of kinds of documentation systems, so that in all that diversity, if I wanted to figure out how to build something out of a bit of this and a bit of this, everything I looked into, I had to connect to some new machine, I had to learn to run some new program, I would find the data, maybe the information I wanted in some new data format, and these were all incompatible. It was just very frustrating. The frustration was that there's all this unlocked potential. In fact, on all these disks, there were documents. So if you just imagine them all being part of some big virtual documentation system in the sky, then, say, on the internet, then life would be so much easier. Well, once you've had an idea like that, it kind of gets under your skin, and even if people don't read your memo, actually he did. It was found after he died, his copy, it was found he'd written vague but exciting in pencil on the corner. But in general, it was really difficult to explain what the web was like. It's difficult to explain to people now that it was difficult then. But then, okay, when TED started, there was no web. So things like click didn't have the same meaning. I could show somebody a piece of hypertext, a page which has got links, and we click on a link, and bing, there'll be another hypertext page. Not impressive. You know, we've seen that. We've got things on hypertext on CD-ROMs. What was difficult was to get them to imagine. So imagine that that link could have gone to virtually any document you could imagine. All right? That is the leap that it was very difficult for people to make. Well, some people did. So yeah, it was difficult to explain, but there was a grassroots movement. That is what has made it most fun. That has been the most exciting thing, not the technology, not the things people have done with it, but actually the community, the spirit of all these people getting together, sending me emails. That's what it was like then. Do you know what? It's funny, but right now it's kind of like that again. I asked everybody, more or less, to put their documents. I said, could you put your documents on this web thing? And you did. Thanks. It's been a blast, hasn't it? I mean, it's been quite interesting because we found out that the things that happened with the web really sort of blow us away. They're much more than we'd originally imagined when we put together the little initial website that we started off with. Now, I want you to put your data on the web. Turns out that there is still huge unlocked potential. There is still a huge frustration that people have because we haven't got data on the web as data. What do you mean, data? What's the difference? Documents, data? Well, documents you read, okay. More or less, you can read them, you can follow links from them, and that's it. Data, you can do all kinds of stuff with the computer. Who was here or had otherwise seen Hans Rosling's talk? When Hans Rosling was at TED, one of the great, yes, a lot of people have seen it because it was one of the great TED talks. Hans put up this presentation in which he showed, for various different countries in various different colors, he showed income levels on one axis, and he showed infant mortality, and he showed this thing animated through time. So he'd taken this data and made a presentation which just shattered a lot of myths that people had about the economics in the developing world. He put up a slide a little bit like this. It had underground all the data. Okay, data is brown and boxy and boring, and that's how we think of it, isn't it, data? Because data you can't naturally use by itself. But in fact, data drives a huge amount of what happens in our lives. And it happens because somebody takes that data and does something with it. In this case, Hans had put the data together. He found it from all kinds of United Nations websites and things. He'd put it together, combined it into something more interesting than the original pieces. And then he'd put it into this software, which I think his son developed originally, and produced this wonderful presentation. And Hans made a point of saying, look, it's really important to have a lot of data. And I was happy to see that at the party last night that he was still saying very forcibly, it's really important to have a lot of data. So I want us now to think about not just 2 pieces of data being connected or 6 like he did, but I want to think about a world where everybody has put data on the web, and so virtually everything you can imagine is on the web. And I'm calling that linked data. The technology is linked data, and it's extremely simple. If you want to put something on the web, there are 3 rules. First thing is that those HTTP names, those things that start with HTTP:, we're using them not just for documents, now we're using them for things that the documents are about. We're using them for people. We're using them for places. We're using them for your products. We're using them for events. All kinds of conceptual things, they have names now that start with HTTP. Second rule, if I take one of these HTTP names and I look it up, I go and do the web thing with it, and I fetch the data using the HTTP protocol from the web, I will get back some data in a standard format, which is kind of useful data that somebody might like to know about that thing, about that event, who's at the event, whatever it is, about that person, where they were born, things like that. So the second rule is I get important information back. The third rule is that when I get back that information, it's not just got somebody's height and weight and when they were born, it's got relationships. Data is relationships. It's interesting, data is relationships. It's got this person was born in Berlin, Berlin is in Germany, and when it has relationships, whenever it expresses a relationship, then the other thing that it's related to is given one of those names that starts HTTP. So I can go ahead and look that thing up. So I look up a person. I can look up then the city where they were born. Then I can look up the region it's in, and the town it's in, and the population of it, and so on. So I can browse this stuff. So that's it, really. That is linked data.
So by the late 1990s and the early 2000s, the internet was primarily used for email and web page display. I got my first computer in 1999. It was a gigantic Mac. It looked like you had a spaceship sitting on your table. And it was so difficult to stay on the internet because you had to dial up, first of all. And if while you were ringing, they had to ring and ring and ring, and then you'd get connected. And if anybody tried to call you while you were online, it would knock you off. So all that work you just did was ruined because somebody was trying to call you. So we've come a long way, baby. By 2005, it had evolved into a more powerful social network. So 2005 started the whole social network aspecting of the internet. Web 2.0 comes in. It encourages media convergence. That's different types of software applications working together. You no longer needed to be a computer expert to do these things. There was instant messages, there's Skyping, Google Hangout, iChat, social networks like Facebook, Twitter. Probably some of you are into Instagram. And then there were blogs. There still are. Blogs were huge back in the mid 2000s, early 2000s, mid 2000s, and then wikis and the semantic web, which we'll get into a little later. Web 3.0 on its way. Changes can't always be predicted. How content will be consumed, paid for, and distributed is still uncertain. It promises new innovations, greater bandwidth, more 3D applications, layered databases, which you heard Tim Berners-Lee talking about, major linking through databases. It'll become more personalized and targeted, as you're noticing your advertising is already getting that way, and there'll be more mobile connectivity and convergence.
To talk about the semantic web, if you're new to this subject. And to do so, I'm going to have to give you a brief history on information, and in particular how information is connected. So if we go back before the internet, before the World Wide Web, what you have is scientists and individuals writing long free-form documents that had references to other documents, and those references were in the form of citations. Now, as a consumer of one of these documents, what you would have to do is read the citation and then send out via mail for a copy of the document, or you'd have to go to your library. And this was really tedious. So from the point of view of the consumer, what you really had was a world where there was tons of documents all over the place, some accessible to you, some not accessible to you. But that burden was on you in order to follow the citations. Now, the web, the great invention, was the hyperlink. So if I'm reading a document that has a hyperlink, I can just click on that link and boom, I get the next document in the chain of documents, right? I can go right to the source of the reference. Now this, as a consumer, is amazing, right? It saves a ton of time. However, from a technical perspective, there was a lot of things that had to happen. And I'm going to go through that history in order to enable you to really appreciate what the semantic web brings to the table on top of this. So if we go back to the hyperlink and then we say, okay, tons of documents are on the internet. They're all linked to each other via hyperlinks. What does that look like? Well, it looks kind of like this diagram. You've got a bunch of documents and there's arrows between the documents. Underneath, in order to make that happen, what you've got is a bunch of computers, and the documents are sitting on the computer. So for example, technically speaking, this document that I'm reading is sitting on this computer over here. And what the hyperlink does is it basically says, there's another document on some other system somewhere that has this information. So before the web and when the internet was very new, all of these connections had to be done by hand. It was extremely tedious. You had to say, well, this other server is residing on this other network, and you've got it, and here are the user credentials to the other network, and blah, 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 blah. But eventually, you could actually link these things up. The great invention of the internet early on was that the internet cloud sort of abstracted that whole connectivity process away from you, so that instead of having to worry about where the other document is physically residing, you can just give it a little address, and you've got a hyperlink, and that's the way that everything connects. So the great advantage of Web 1.0 is that even though you might have tons of different servers in this diagram, you don't have to think about them as being servers. You could just think about them as being documents. You don't care about the servers. So the real advantage is that the whole mechanism, the whole network structure, the physical layer is abstracted away so that you don't have to think about it. And I want you to keep that in mind as we go forward and talk about the semantic web and how it goes even beyond this. But before that, we'll talk about Web 2.0. So Web 1.0 was documents. Web 2.0 is applications. You had LinkedIn and MySpace and Yelp and Gmail and all those things that you interact with today. And they go beyond just the data that you're storing on the computers. Now, the big drawback to these systems is that they don't interoperate. So if you ever update your profile on LinkedIn, you get a new job or something like that, Facebook doesn't automatically know about it. In fact, you've got to double enter. You've got to go to LinkedIn, you've got to enter the data, then you've got to go to Facebook, and then you've got to go to the section in Facebook where you enter your employment information, you've got to enter it there, and probably other places as well, right? Because they don't share information. Data is not connected to each other, even though you might have a link here and there between the systems. Now, companies have this very same problem, right? You've got different databases, your financial system, your actuarial system, your HR system within companies that don't really connect to each other, right? The data is stored in one system, and you've got double entry problems, and it's expensive to connect these things up in any reasonable way. So the whole idea of Web 3.0 is to connect the data, not just the documents, not just high-level links between applications, but to connect the data at a lower level so that an employment information, to go back to the LinkedIn example, stored on LinkedIn would be shareable and connectable in a way in Facebook that it's not today. So to break that down, if we look at back our Web 1.0 and Web 2.0 document silos and data silos, you get the systems, Facebook and LinkedIn, and maybe you get something like New York Times. And today, information about Evan Sandhouse, who's a prominent semantic web practitioner, will be stored 3 different times in 3 different ways and possibly conflicting on all of those systems. Information such as his name, his address, publications that he's written, conferences that he's spoken on, stuff like that. So what we want to do is get beyond just the document. We want to get to the data level so that specific data elements can be referenced between documents so that there's maybe one source of key Evan Sandhouse data and Facebook can just reference it. And if the data is updated, then Facebook automatically knows that the data is updated. So the idea is that instead of having URLs between documents, you get URLs between facts, right? And it's at a lower level than just the document, on a lower level than just the application. And in doing so, the great advantage is that you no longer have to think about specific documents. You just have to think about data and information. Now, this is extremely powerful, right? In the same way that Web 1.0 enabled you to not have to think about where the information was sitting. You didn't have to think about the network layer and the machine layer and all this sort of stuff. The semantic web enables you to not have to think about specific document locations. All it asks you to do is to connect basic information up. And once you do that, the whole world, from a data perspective, makes a lot more sense and can be kept a lot more organized. So that's the basic idea of the semantic web, is that It represents information at a lower level than documents, little facts, and it connects them up. Special thanks goes out to Sir Tim Berners-Lee, the creator of the World Wide Web, for all the images that were used in this presentation.
Now let's talk about the economy of the internet. The internet is beginning to make money, but in the beginning it really didn't. We had internet service providers. It started with a company called AOL, which many of you have probably heard of, and you had to pay $19.99 a month, and you got your email, and you got your news, and you got to use a web browser. Well, broadband took over. We were no longer using dial-up. AOL now loses the monopoly because others have gotten involved. Now we have web browsers. Microsoft, Apple, Google, they all become major players. Internet Explorer was dominant, although I'm a Mac girl, so I use Safari and Firefox. Chrome is what a lot of my students use. I'm starting to get on board with the Chrome. And then there were the directories and search engines. Obviously, Google dominates that field. As we say, you Google it. Email became a huge part of what people did, specifically in business on the internet. And if email is not something you do on a regular basis, I would suggest you stay up on it, because once you get into business, that's what you'll be using to communicate. Web advertising's early roots were with display ads. We called them banners, across the top, across the bottom. You still see them, but they're not nearly as profitable as the companies hoped. Today we use things called sponsored links on search engines, which is a link that's put up there, and the more click-throughs you give it, the more you click on the link, the more the advertisers pay. And then there's the social networking sites that are sending targeted ads. We've all seen these. You go to your Facebook and you see an ad about something you had just Googled hours before, and that is called targeted advertising. Here we go.
Ads in magazines or on billboards show the same message to everyone reading them. But for online ads, we can switch things up. Online ads can use geographic targeting and cookies to target their messages so you see the right ad at the right time. Ad servers can deduce a user's geographic location by their IP address, which is like a zip code for your computer. For example, by knowing your IP address, advertisers can serve an offer specific to your area. Ad servers also recognize users based on cookie information. You may see more relevant ads based on prior visits you've made to an advertiser's site. Say you've just been eyeing a pair of super cool kicks on a company's website. Later in the day, you might see an ad from that same company where they're offering free shipping. Free shipping sounds great, but let's talk about those cookies. Cookies are text files assigned to your browser once you visited a website. When you go back to that website, it'll see that your browser has the cookie and will read it. The cookie helps the site recognize your browser and will restore any information you might have entered before. You can see examples of cookies in action if you return to a site and don't have to sign in again, or when you return to a retail site to find your items patiently waiting for you in your shopping cart. These are examples of first-party cookies, cookies set by the site that you're on. It's important to keep in mind that cookies are anonymous. The text file associates a random unique number with the computer and browser. So, if you use different devices or browsers to visit the same website, each browser will have a different cookie. There are also third-party cookies. These are used by ad servers. Online ads use third-party cookies to recognize the same user across multiple websites. That free shipping ad we mentioned earlier, that's an example of third-party cookies at work. When you went to supercoolkicks.com to check out those shoes, they allowed their ad server to set a third-party cookie on your browser. So, when you visited that news site later in the day, the ad server recognized their cookie and used the information in it to show you that offer. Geographic targeting and cookies help advertisers show relevant messages to potential customers, and they sometimes even help customers get deals on stuff they buy online.
There's also non-commercial web, which is called open source. Open source software is free for anyone to use. The source code can be updated by anyone. You've probably heard of Linux. Firefox is open source. Audacity is a sound program. WordPress, there's a pay for WordPress, but there's also a free for WordPress, and that's their open source software. There's digital archiving. This is when the internet has decided to archive important things in our history. And I want to share this webpage with you. This is called archive.org, and it is a site and a group of people that are looking to archive our history on the web. So as you can see here, it is a nonprofit library of millions of free books, movies, software, music, and more. It's really a pretty cool place, and I would suggest that you go through it, and let's take a quick look at some text, some books that are available. And as you can see, there are just lots of them. Lots and lots of libraries you can go to, look at books. There are movies, there's music, there's all kinds of really cool stuff. So if you get a chance, it's called archive.org, and it's free for you to use. It's called open source. There is also the Open Content Alliance, which is another organization that is trying to put all books in the public domain. They focus on collective ownership as a public resource. And a Google Books program is available too, but that is for pay. Security and appropriateness. Information security, that's a big deal these days. The government surveillance of what they're allowed to see, what they're not allowed to see. Online fraud, there's something called phishing. Those are fake emails telling you to update your account. They're asking you for your social security number or your bank account. As I'm sure you know, don't give them any of this information. If you get something that seems like it's from a bank, call your bank and ask them what's going on, because that's probably a phishing scam. Unethical data collecting, those are cookies. They're gathered from your searches. And then there's spyware. You download free software and all these pop-ups come up, and that's somebody trying to abuse your computer. Online predators are obviously an issue on the internet for young children, and that's why we have the Children's Internet Protection Act of 2000. Closing the digital divide. Access increasing among some groups. Older Americans for sure. My mother, who's 85 years old, just got a new laptop, and she just got on Facebook, and now you can't get her off. So older Americans are definitely getting involved. And less educated citizens, it seems as though everyone has a smartphone and everyone is connected to the web somehow. Many individuals still lack internet access. That is extremely low-income citizens and people in developing countries, although Bill and Melinda Gates are attempting to remedy that by creating libraries in places where people can get internet access. Here is the open internet.
Today, the FCC's open internet rules go into effect. There's now a referee on the field to protect consumers and innovators online. Not only does that mean no blocking, no throttling, and no fast lanes, it also means vigilant oversight as the internet continues to evolve. After a decade of debate, these rules finally provide strong safeguards for free expression and innovation on the internet, and at the same time promote continued investment in our nation's broadband networks. For more information, go to fcc.gov/openinternet.
Ownership and customization. Commercial growth has definitely outpaced nonprofits, which is putting nonprofits in a difficult position on how they can get people's attention. Large corporations have gained a lot of control of the internet. Defending of the digital age, it does make life more enjoyable, and there's mass customization, which inspires creativity. And others want to regulate the net more. commercial interests have too much control in many people's opinion, and information is determined, limited, and controlled by corporate interests. What do you think about that? You think it's a free and open net, or do you think you're controlled? Something to think about. Here are a few things I'd like to share with you that make the internet really interesting to me.
Thank you, MIT.
That's the sixth thing.
All right.
Can I just explain what that is?
Yeah.
Yeah,
In case it's not clear.
that was going to be the very next thing.
He's wearing a camera, a computer, and a video projector, so it wasn't a simulation. The camera looks at reality, it knows context, and then it annotates it and projects it. And the projection is shared, so anybody in the vicinity can see it.
Right. When we all watched that earlier, my question was, am I watching a mock-up of something?
No,
Or is there a guy with a camera filming?
No, this stuff actually works, and although it's not commercialized, the thing that's so important about this is the term that you use is augmented reality. What's happening, I find this very profound, that we are finding ways to allow a computer or a program to participate in the same sensorium that we live in. So the machine, the computer sees what we see, it hears what we hear, it sees gestures, and it can begin to participate in the medium of communication that we use as human beings, as opposed to sitting at keyboards and having to do things so artificially. I get very excited about that because the more a computer can experience our world, the more likely the software will be able to, let me use the word, understand our world better and communicate with us because of our shared experience. So I find this to be a very exciting development.
So augmented reality is something I studied in my doctoral program. My doctoral program was with emerging media, and augmented reality is something that I find really fascinating. Now, that's not what you just saw in that video isn't being done on a commercial basis yet, but in a short while it will be. As a matter of fact, we're using it in our yearbook this year. I am the advisor to the yearbook, and we are creating augmented reality within the yearbook. So certain pictures you'll put your phone up against, and the picture will come to life, and it'll show you video. So that should be pretty darn cool. Another area that I studied in my PhD was holographic technology. And here's a little example of that.
She dances in the sheets at night. She dances to his needs. She dances till he feels just right until he falls asleep. She dances at the crack of dawn and quickly cooks his food. She can't be late, can't take too long. The kids must get to school. She's a slave to the rhythm. She's a slave to the rhythm. She's a slave to the rhythm.
And there's one more thing I wanted to share with you. It's called Second Life. It is also an augmented reality world within the computer. If you've never been there, it might be fun to experience it. My advanced web class is going to experience it. I had to take 2 classes inside Second Life when I was getting my PhD, and it's a really interesting way to learn. I was a really bad flyer, and you might understand what I mean if you've ever done this or once you see this video, but I kept getting lost because they'd all go on ahead of me, and then I'd have to ask for a teleport. Yes, it sounds very, very out there, doesn't it? But it's a really interesting example of what we can do with the internet. A lot of video games are based around this augmented reality. So let's take a look.
What is Second Life? Second Life is a virtual world with 16 million accounts and right now 60,962 people or residents in world. Here is a useful definition of a virtual world. A synchronous, persistent network of people represented as avatars facilitated by networked computers. This is my avatar, my in-world representation. I can change her appearance easily and could choose to be something other than human. Using her, I move through the virtual world, walking, flying, teleporting, and can do animated activities like dancing or surfing. I can also build objects. Second Life is owned by a company called Linden Lab. Basic accounts are free, but it costs money to own land. You can find versions of most in-world objects for free, but really nice, well-made objects cost money. Like life, Second Life is different things to different people. Everyone has their own version of Second Life. There is no game, at least not one central game. All the content is created by the residents, and people can design and refine their avatar and their environment how they wish. People find their own things to do, often by joining groups or attending events to find others who are interested in the same things they are. People make friends and communicate in text chat and over voice, and sometimes even meet in person. Sometimes avatars remain anonymous, and sometimes you find out who else someone is. There is an economy with a currency called lindens, land for sale and rent, music streamed live and performed by animated avatars, an art scene, shops, role-play games, places to explore, social events, bars and clubs, relationships, sex, sports, politics, education, religion, museums, libraries. If you can think of it, it is probably here in Second Life. And if it isn't, you could start it up. The creative possibilities are amazing. In the future, I think, virtual worlds will become a larger part of how we interact online. As the technology improves, the line between being in the actual physical world and being in a virtual world will become more permeable. It used to be that making a telephone call was a big, huge deal, involving stationary machines and an operator. Now we stop talking on the phone because we are walking up to the person we are talking to on our cell phone. The transition feels seamless. I believe that in the future, we will move in and out of virtual worlds like that, seamlessly, and our avatars will be another aspect of who we are. It makes me think the future might be very, very interesting.